So, welcome to 9th lecture on computational mathematics with Sage Math. In the previous lecture, we introduced a very important module called NumPy, and we saw what some of the functions inside NumPy. Two important things that we saw was a range inside NumPy and np.array function, that is numpy.array function inside NumPy library, and we also saw that some of the functions that actually the math, whatever functions you have in math module, all these functions are available inside NumPy module also. However, these mathematical functions can operate on any list, NumPy array. Okay, that is what we saw. So, now let us look at some more operations on NumPy array. So, as I said, if you create one dimensional array, it can be thought of as vector. So, let us look at some of the operations that we know that can be applied on vectors. So, let us define a vector v. So, first of all, let me import. So, import NumPy as NP, import, so spelling mistake, import NumPy as NP, and let us define a vector v as np dot array, and inside that you give the list. Suppose we want to define a vector in 3 dimensions, so I will say 3 minus 2 and then 4, and another vector, let us say w, this is np dot array. Inside that, let us the coordinates are 5 comma 2.1 or 2.5 comma 3. Let us say 8. So, these are the two vectors. Now, if these are the two vectors, you can apply any operations on these vectors. So, for example, you can add v plus w, you will get this. You can even multiply v and w. So, if I say v star w, you will get the term by term multiplication. So, 3 into 5 is 15, minus 2 into 2.5 is minus 5, and then 4 into 3.8 is 15.2. So, this star gives you term by term multiplication, and this you could not have done in simple Python list. You have to write a small code for multiplying term by term two arrays, two lists. Okay, but here it is available. But in case you have two vectors, you also have notion of dot product. Of course, any scalar linear combination you can write. You could have written 2 times v plus 3 times w, or minus 3 times w. It will 3 times w. It will work. So, any scalar linear combination of vectors you can find out. Suppose we want to find out dot product. So, in that case you can simply say v dot and then w. It will give you dot product. If you want to find out let us say length of a vector, then you may need to use lin-alg package. So, let me import that. So, let me say from NumPy import lin-alg package, and let us say this I will import as LA. Okay, and inside this lin-alg package, again you have several methods. So, if I say LA dot and press tab, then you will see, for example, you have determinant, eigenvalues, eigenvectors, inverse, and things like that. Okay. Norm is the length of the vector. So, if I say this norm and if I say v, it will give me length of the vector, which is same as a square root of the first coordinate square plus second coordinate square plus third coordinate square. That is what is called L2 norm or Euclidean norm. You have also other norms you can find out. Okay. Similarly, you can find out even cross product. So, if you say NP dot cross, and then if I say V comma W, you will get cross product. So, all the standard methods of vector operations are available when you create one dimensional array using NumPy array. Okay. So, that is a very nice feature, and other you should try to explore other methods that you know, or other operations that you know on vectors. Not only vectors in 2 dimensional, 3 dimensional, you can have vectors in any dimension, and all these operations can be applied. Okay. So, now let us look at how to define 2 dimensional array or matrices, and let us see some of the standard methods on matrices. Okay. So, let us add some input cells here. So, how do we create 2 dimensional array? So, again the method is very simple. You can use same function np.array, and these entries you have to put, it is a list of list. So, that means you need to put the list inside a list. Okay, that is the. So, let us create that. So, if I say for example, let us say A is equal to np dot array, and this is, let us say this is the list, and inside that each row you have to write in a square bracket. So, the first row is, let us say 1 2 3, second row is minus 4 2 7, third row is 9 10 minus 11. This is a 3 by 3 matrix. You can find out what is A dot let us say size of A. So, this is a size 9, that means it gives you the number of entries inside this. If you want to find out dimension of this, you can say A dot shape, A dot shape, this is 3 by 3. So, this is a 3 by 3 matrix. You can even reshape this matrix, you can apply. So, let us see what you mean by reshaping. So, let us generate, suppose we want to generate a matrix of order 4 cross 5, okay, matrix of shape 4 cross 5, and the entries are random integers from, let us say 1 to 100. So, first we need to generate a list of random integers between of 20 integers between 1 and 100. So, how do I generate that? So, we will first import random. So, import random, and then create a list. So, list, let me create as a which is a list of random numbers. So, this is n random dot rand int, and with from 1 to 100, and this we want to generate 20 times. So, for I in range 20. So, these are 20 random numbers, and we will create a array of this. So, np dot array, this is a list of 20 numbers. Now, this, so let us see what is A. A is 20 random numbers as an one dimensional array. Now, let us say A dot reshape. Suppose we want to reshape as a 4 cross 5 matrix. So, let me put it here and put it in the next input cell, so that you will also see what is happening. So, A dot reshape, and we want this to be 4 cross 5. Okay. So, this is a 2 dimensional array, and how it has created? It has created first row is first 5 numbers, next row is next 5 numbers, and so on. Of course, there is a facilities, you can look at reshape function, you can reshape column wise also, it should be possible. But however, so let us put this in M as a matrix. Okay. Now, if you want to find the transpose of this matrix, you can simply say M dot capital T. This is a transpose of this matrix. If you want to write M star M, this will give you, this is a term by term multiplication as we saw in case of array. Suppose you want to have another matrix. So let me say my matrix N is actually transpose of M. So M dot T. You could also use transpose function. So M dot transpose will also give you the transpose. So I have two matrices M and N. One M is 4 cross 5 and N is 5 cross 4. So of course M into N makes sense. You can multiply M and N. So for example, if I say M star N, this will not work because M star means term by term multiplication. If you want to use matrix multiplication, actually matrix multiplication of two matrices can be thought of as extension of dot product. So the same function M, we looked at how to find dot product of two vectors using dot function. So here also it will work, M dot and then dot, and inside that bracket you write N. So this is actually matrix multiplication. It is multiplying matrix M with N. So this is matrix multiplication. Right. So there is another way of multiplying two matrices. You can also say M and at the rate N, M at the rate N. This is also matrix multiplication. Now some of the other operations on matrices you can find out. For example, if I want to find determinant, so if I say M, now M is not a square matrix, so you cannot find determinant. So let us store M into N, which is actually a 4 by 4 matrix. Let us store this into, let us say, matrix D. This is D, and let us see we want to find determinant of this matrix. So how do I do that? So if I say M dot, sorry, this is D dot, and then press tab, you may not see the determinant here. There is no determinant function, but where it is in linear algebra package. So we have not imported linear algebra package. So no, we have already done it. So let us say LA dot determinant det of D. So this is a determinant. This is quite big, right? So if I want to find out inverse of this, I can simply say LA dot inverse of D. This is the inverse of this matrix. There are other functions like if I want to find out rank, I can say LA dot I think matrix rank and then D. This will give me matrix rank. So this is a matrix rank of D is 4. So it is, that is why it is a invertible matrix. The other operations you can try to explore this lin-alg package, and inside that you can look at other functions. For example, you can find out trace. So you can say D dot trace. This trace is sum of the diagonal entries, right. So we know how to multiply matrices, how to find transpose, how to find determinant, how to find inverse, and other operations you can look at. Similarly, you can also find out various row operations, etc. You can also define higher dimension array. So for example, let us say we want to define a 3-dimensional array. So how do we do that? So all you need to do is, so 3-dimensional array will be actually a list of matrices, So suppose we want a list of 3 matrices. So let us say first matrix is 3 by 3 matrix 1 2 3 4 5 6 7 8 9. Second matrix is from 10 to 19, again 3 cross 3, and third matrix is 20 to 29. So this is a 3 dimensional array. Now how do I create? So, I will simply say np dot array and inside a list m1, m2, m3, and if you look at what is this list. So, this is a list of matrices, list of 3 cross 3 matrices. Instead of 3 cross 3 matrices, you can have other dimension also. So, this is a 3 dimensional array, and you can create 4 dimensional array, 5 dimensional array, etc. Suppose we want to find out how to get particular entries inside this. So, if you have a matrix, you can take any slice of it. Similarly, you can take any slice of any 3 dimensional matrix array also. So, how do we do that? So, for example, if I say what is m of 1. So, m of 1, what was m? M was list of 3 matrices. So, m1 will be second matrix in that list. So, m1 should be this small m2, which is a 3 cross 3 matrix starting from 10 going up to 19. So, that is what you see here. M1 is 10, 11, 12, 13, 14, 15, 16, 17, 18. So, this is the. Now, suppose I want to find out first column of this. So, this is a matrix. I want to find, let us say, second column of this. So, second column of this, how do I get? If I say 1 here, it will give me second row, right, that you can check. This is a second row of this. I want second column. So, second column means you look at all the rows and then second column, all the rows. This means you can have A colon B, that means starting with 8th row to B minus 1th row, that is what it will give, and this is 1. So, this will give you the second column of M1, that is what you see 11, 14, 17, and if I want to find out, let us say this of first entry, this is 14. So, this we could have also found using just writing m of 1 comma 1 comma 1, right. So, this is 14. So, that is how you can take any slice of any array, slice of any array. Okay. So, NumPy has very nice features to deal with arrays of any dimension. Usually in mathematics, we make use of 1 dimensional array, that is vectors, 2 dimensional array matrices. Sometimes 3 dimensional array, you can think of 3 dimensional array as a possibly color image. Any color image can be thought of as 3 dimensional array. Okay. So, I expect all of you to explore other methods or operations on matrices. So, create some random matrices and you can deal with other operations that you know. Similarly, you can also look at another thing. For example, if you have a matrix, let us say for example, we created a matrix, let me see D, we have created a matrix D. Okay. This is the matrix D, 4 cross 4 matrices, and suppose we apply D, look at D dot flatten, what will it do? It will flatten this list, 2 dimensional list, and make a 1 dimensional list. And how it flattens? Actually, if you simply look at, let us see how it has flattened. So, let us look at what is D and then compare this D with D flatten. So, D is this, so it has flattened row wise, right, and that is how you actually we created this matrix using reshape command. So, once you have a matrix, you can flatten it. If you have a 1 dimensional list, you can make a matrix using reshape command. So, all these functionality are available in this. Okay. Now, let us look at, as I said in the beginning of yesterday's lecture, that Python array requires less memory and it is faster. So, let me just give you one example. Why do I say this? So, let us create a list using range function and also a list using arange function from NumPy. Okay. So, we will import another module called sys, which will provide some functions to find out the size of any item inside a list. Similarly, let us import time module to find out time it takes to do various computation. So, let us create a n of this 10 to the power, let us say 5. So, this is for example list of 1,000,000 entries, and L1 is range n and L2 is also range n. So, the L1 and L2 are two lists, and let us say M1 and M2 are again same list, but created using arange function from NumPy library. Now, let us see, suppose we want to find out size of each entry inside L1. So, what is size of each entry inside L1? That is can be obtained by sys dot get size of. So, this is size of each entry is 48 byte actually, and so what is the total size? So, this we will multiply by n. This is the size of entire list L1 and similarly L2. Whereas, if you want to find out size of each entry inside M1, which is created as an array, one dimensional array of same length, and so this can be obtained using M1 dot item size, and so this is, if I say this is 4, each entry has size 4 only, whereas for list it was simple list it was 48. So, that is the huge difference. So, if I multiply this by star n, this is the size of entire list. So, as compared to this, the memory required for storing array using NumPy is quite small. So, that is why you see the Python array requires less memory in order to store any list. Now, suppose we want to find out, let us say we want to multiply two arrays component wise, term by term. We saw that in case of if you have a two lists, you can simply say multiplication in between, star in between, whereas star in between for a simple Python list will not work. So, what we will do is we will create a simple comprehensive for loop for this. So, x star y for x and y in zip L1 L2. Zip L1 L2 will create a list of tuples of L1 and L2. So, each coordinate of suppose L1 has x size and L2 has y I, then it will create a list of tuples of xi, yi going from 1 to 10 to the power 5. So, this is multiplication, and in the beginning let us say store the beginning time, the initial time as time dot time, and then you find out this, and then find out again what is the time end time, and subtract from subtract initial time from that, and then since it is going to be very small, let us multiply this by 10,000. So, it will give you in millisecond. So, it says that the time required for completing this term by term multiplication is 33.97 millisecond. Whereas, same thing if we do it for multiplying two arrays term by term, let us say M1 star M2, M1 and M2 were one dimensional arrays created using NumPy array, and the same thing initial time you find out M1 M2 I have called for the list or array M1 into M2, and then again compute the time it takes, and then no, I have to run once more. So, you can see here this time taken is almost 1 millisecond. So, compared to this is quite fast. So, that is what I meant by saying this NumPy array requires less memory and also it is fast. So, that is one reason why the computation with array created inside NumPy is preferred. Okay. So, at the end let me give you simple exercises which you should do. Of course, we will be posting the solutions of these problems, but you should not wait for us to post the solution. These are very simple exercises. So, first exercise is to create two vectors u and v using NumPy array and hence find the angle between them in degree. So, angle can be obtained using dot product. And create an user defined function to find the orthogonal projection of a vector u v onto u, and suppose p is the orthogonal projection. Just for your convenience, I have given you the formula for orthogonal projection of v onto u. So, it is v u dot v divided by length of u square times u. We have already seen how to find the length. Okay. And the next one is create three vectors u v w in 3 dimension and then find out the volume of the parallelepiped generated by these u v w. So, you must have seen as an application to cross product and dot product how to find the volume of this parallelepiped. Another exercise is to create a 6 cross 8 random matrix of integers. Integers are varying from -50 to 50. We already created one 4 cross 5 matrix, and then show that the rank of A transpose is same as rank of A transpose A, which is also rank of A. In fact, you should show that rank of A transpose and is same as rank of A is same as rank of A transpose A. Okay. And another problem is inside LinAlg package there is a function called solve and which can solve system of linear equations. So, look at suppose you take a system of linear equations A x equal to b, where A is this 4 cross 4 matrix, B is this. Try to solve this system of linear equations using NumPy. Inside NumPy use LinAlg. So, inside LinAlg there is a function called solve. Okay. So, these are the 5 simple exercises, you should be able to solve them. Thank you very much. I will see you in the next lecture.